Our planet, this remarkable blue marble spinning in the vastness of space, holds secrets deep within its core. We often see it as a calm and stable home, a world of green forests and blue oceans. But beneath this tranquil surface lies a world of immense power, a world of fire and fury. Sometimes this power bursts forth in a truly spectacular display. It builds mountains that scrape the sky and spews rivers of molten rock across the land. These are volcanoes, one of nature's most awesome and breathtaking phenomena. They are windows into the very heart of our world, reminding us that the Earth is a living, breathing, and ever-changing entity. For thousands of years, humans have watched these fiery mountains with a mixture of fear and wonder. Ancient civilizations told stories of gods and monsters living inside them, believing their eruptions were signs of divine anger. Today, we understand the science behind them, but that does not make them any less magnificent. To witness a volcano is to witness the raw, untamed power of creation itself. It is a force that has shaped our continents, created islands from the sea, and even influenced the air we breathe. They are a powerful reminder that the ground beneath our very feet is not as solid or as permanent as we might think. The sheer scale of a volcanic eruption is almost impossible to comprehend. It can send clouds of ash miles into the atmosphere, so high that they can travel around the entire globe. These clouds can turn day into night and affect weather patterns for years to come. The sound can be deafening, a roar that echoes for hundreds of miles, a true testament to the immense pressure being released from deep within the earth. The lava that flows from a volcano is rock that has been heated to such an extreme temperature that it becomes a glowing liquid river, destroying everything in its path but also creating new land where it cools. But what exactly is happening to cause such a dramatic event? It is not magic, nor is it an angry monster. It is a natural process, a complex and fascinating dance of heat, rock, and immense pressure. The story of a volcano begins many, many miles below the surface, in a place we can never see with our own eyes. It is a journey that starts in the scorching depths of our planet's interior. To understand these magnificent mountains of fire, we must first travel downwards, through the layers of the earth, to discover the secret science that gives them their explosive power. Imagine our Earth as a giant, layered onion. On the very outside is the part we live on, a thin, cool, and brittle layer called the crust. It is like the skin of an apple, surprisingly thin compared to the rest of the planet. It is broken up into giant pieces, like a jigsaw puzzle called tectonic plates. These plates are constantly, slowly, drifting across the surface, a movement so gradual we cannot feel it. Beneath this crust lies a much thicker layer known as the mantle. The mantle is not quite liquid, but it is not entirely solid either. It is a region of incredibly hot, dense rock that churns and flows over millions of years like a thick, simmering stew. Deep within this mantle, the temperatures are so extreme that rock can begin to melt. This molten rock is called magma. It is a fiery, gooey substance, a mixture of melted minerals, dissolved gases, and solid crystals, all blended together under enormous pressure. This magma is less dense than the solid rock surrounding it, and just like a cork held underwater, it wants to rise. It collects in vast underground pools known as magma chambers. These chambers are like giant subterranean cauldrons, holding this immense heat and energy, waiting for a chance to escape to the surface above. The journey has begun. The Earth's crust is not equally strong everywhere. In some places, it is thin or fractured. This is particularly true at the edges of the tectonic plates. Here, the giant puzzle pieces of the crust are either crashing into each other, pulling apart, or sliding past one another. These active boundaries create weak spots, providing perfect pathways for the rising magma. As one plate is forced underneath another, a process called subduction, it heats up, melts, and creates even more magma. In other places where plates are pulling apart, magma rises to fill the gap, like honey welling up in a crack. These weak spots are the birthplaces of volcanoes. The rising magma, driven by its buoyancy and the immense pressure from below, forces its way upwards through cracks and fissures in the crust. It is a slow but relentless journey towards the surface. As it ascends, it can melt the rock it passes through, adding to its volume and changing its chemical makeup. It is a dynamic and powerful process, a hidden world of geological activity occurring miles beneath our feet. This is the engine room of the volcano, the forge where the fuel for a spectacular eruption is slowly and patiently prepared for its dramatic debut. As the magma continues its long journey upward, it eventually finds a main channel, or conduit, leading to the surface. With each surge of new magma from the chamber below, it pushes further up, building a mountain layer by layer. Each time lava erupts and cools, it adds another layer of solid rock, making the volcano grow taller and wider over thousands or even millions of years. This is how famous volcanic mountains like Mount Fuji in Japan or Mount Rainier in the United States were built. They are not just mountains of rock, they are monuments constructed by countless eruptions, a testament to the persistent power rising from below. Inside the volcano, something crucial is happening to the magma. As it gets closer to the surface, the pressure from the overlying rock decreases. This change in pressure allows the dissolved gases within the magma, gases like water vapor and carbon dioxide, to start coming out of the solution, forming tiny bubbles. It is very similar to what happens when you shake a bottle of soda and then open it. The bubbles expand rapidly, and the pressure builds dramatically inside the magma chamber and the conduit. The volcano begins to swell, the ground can shake with small earthquakes, and steam may begin to vent from cracks near the summit. The fate of the eruption, whether it is a gentle flow or a violent explosion, depends heavily on the magma itself. If the magma is thin and runny, like warm honey, the gas bubbles can escape easily. This results in a relatively calm eruption, where lava pours out and flows smoothly down the sides of the volcano. This is common in volcanoes like Kilauea in Hawaii, which creates vast new fields of black rock. These lava flows are destructive, but they are far less explosive and dangerous than the alternative. The mountain seems to breathe fire rather than explode with it. However, if the magma is thick and sticky, like peanut butter, the gas bubbles get trapped. The pressure builds and builds until it becomes truly immense, turning the magma chamber into a geological pressure cooker. Eventually, the strength of the rock above can no longer contain it. The result is a cataclysmic explosion. The magma is blasted into tiny fragments of ash, rock, and glass, which are hurled miles into the sky in a colossal eruption column. This is the secret behind the most explosive volcanoes like Mount St. Helens in 1980 or the ancient eruption of Vesuvius that buried Pompeii. It is the trapped gas that provides the devastating explosive force. While volcanoes are undeniably destructive forces of nature, capable of immense devastation, they are also fundamental to life on Earth. They are a crucial part of our planet's life cycle, a force for creation as much as destruction. When a volcano erupts, it releases gases from deep within the Earth's mantle. Scientists believe that the very atmosphere we breathe today was formed over billions of years by gases released from countless volcanic eruptions. They helped to create the air and water that allowed life to begin and flourish on our young planet. Without them, our world could have been a barren and lifeless rock. Volcanic activity is also a master land builder. The entire state of Hawaii, a beautiful chain of tropical islands, was created entirely by volcanoes rising from the floor of the Pacific Ocean. The lava that flows from volcanoes may destroy what is in its path, but once it cools, it forms incredibly rich and fertile soil. Over time, this soil breaks down, releasing valuable nutrients that allow lush vegetation to grow. This is why, all over the world, you will find farms and communities thriving on the slopes of volcanoes, taking advantage of the wonderfully fertile ground that the mountain itself has provided for them. Furthermore, the heat from within the earth, so powerfully demonstrated by volcanoes, provides us with a clean and renewable source of energy. This is known as geothermal energy. In places with volcanic activity like Iceland or New Zealand, we can drill deep into the ground and use the natural steam and hot water to generate electricity and heat homes. It is a way of harnessing the very power that creates a volcano and using it for our benefit, a clean and sustainable energy source that comes directly from the planet's own internal furnace. It is a remarkable way to turn a potentially destructive force into a positive one. So, the next time you see a picture of a fiery volcano, remember that you are looking at more than just a mountain. You are seeing one of the fundamental engines of our planet at work. These magnificent structures connect the surface world to the fiery depths below. They are responsible for creating new land, enriching our soil, and even shaping the atmosphere we depend on for our very existence. They are a powerful and beautiful reminder that our Earth is not a static place but a dynamic and constantly evolving world, full of secrets and wonders still waiting to be discovered.